Okay, the next factoring pattern that we need to review is called factoring a difference of two squares. And this is a pattern that we're going to be using most of the year as we get into polynomials. So it's important that we review this. So, in order to use this method, the name implies difference, meaning subtraction, and it really should say two squares, two meaning there's two terms, and squares, meaning that these are perfect square trinomials. So these are the criteria. You must be starting with a binomial, meaning one term, two terms. It must be a difference, meaning we must have a subtraction sign there. And it's not a requirement, but we're looking for A and C to be these perfect square numbers. And as a review, the perfect square numbers are listed here 1, 4, 9, 16, and so forth. Those are numbers that are really important for you to kind of apply. Okay. So recognizing the pattern is one thing, and then what do you do with it is another thing. So, in order to factor this successfully, you need to recognize the pattern. You need to recognize that it's a difference of two things that can be written as something squared. And if it does fit that pattern, here's how you factor it. You take the square root of the first term, so the square root of a squared would be a. The square root of the second term would be b, and your answer becomes a plus b times the quantity of a minus b. Okay, so we're going to do a couple of examples. I'm going to start easy. So if you have something like x squared minus 9, well, first of all, you recognize it's a binomial. It's a difference. The first term looks like something squared, but this last term doesn't necessarily look like something squared. So in your head, you have to realize that 9 is really 3 squared. So if you pick up that this is a binomial that's a difference of two things that are squared, our pattern says that it becomes x plus 3, x minus 3. Okay, so it could be anything like this. It's a binomial, it's a difference. The first term is something squared, the second term is something squared. 81 is a perfect square number, so that factors into m plus 9 times the quantity of m minus 9. Okay, so that's the most basic form of factoring a difference of two squares. But then it gets a little trickier. So let's say that we have something like this. You might notice that 4 and 25 are both on our list of perfect square numbers and that it is a difference. So it looks like it might fall into this category. But what you have to do is you have to figure out what thing is being squared here to get 4x squared. Well, notice that 2x times 2x gives you 4x squared. 5 squared gives you 25. So now it falls into the pattern of something squared minus something else squared. So our factor pattern says that our factors become this. A plus b, a minus b. Okay, now some of you might notice that there's a quick way to go from here down to here, and that's by just taking the square root. When you take the square root of 4x squared, you get 2x. And when you take the square root of 25, you get 5. And that's where these numbers come from. Then one term is adding, the other term is subtracting. Okay, so let's try this one. It's a difference of two squares because I know that 7 squared is 49 and x squared is x squared. So this will factor into 7x plus 6 times the quantity of 7x minus 6. Now it does not matter the order you write these in. You could put 7x minus 6 first and 7x plus 6 second. Okay, so let's take a look at this one. You should recognize that those are perfect square numbers. So as a shortcut way, what's the square root of 121y squared? Well, that's 11y. So both of these terms are going to start with an 11y. And we take the square root of this last term to get 9x and minus 9x. Okay. All right. Just this past year, I saw this question come up on the SAT. And if you recognize that it's a difference, and if you think about these as two squares, even though 6 is not a perfect square number, this is what the solution looked like. This was x and x. And then this, when you take the square root of 6, square root of 6 is an irrational number. So that's the most simplified way to write it. And this is how you would factor those. Okay, so I'd like you to try these. And when you're finished, restart the video and check. Okay, so please check your work on each of these. And this is the one of a key technique called a difference of two squares. Make sure this gets put into your notebook in the next page.